All right, so we are going to be looking at properties of logarithms that you did last year in Algebra 2. So there are five primary logarithmic properties. The first one is if you take log base b of 1, that's 0. Log base b of b is 1. And then remember, this was the product property. If you have the log base b of m times n, that's the log base b of m plus log base b of n. And you can see the corresponding exponential property and why that is. We proved it last year in Algebra 2. Then you have the quotient. The log of a quotient can be expanded to be the log m minus log n. And then you have the power property. If you have log m to the n power, you can bring the power down. All right, so what we're going to do in example A is we are going to expand. So I have a quotient. So this is going to be the natural log, and I'm going to multitask here. The square root is the 1/2 power. So I'm using the quotient property. Then I'm going to use the power property here. I can bring down the power. Now, the natural log of 3x, that's the product property which expands to a sum. But I want you to notice that what I did is I put a grouping because I have to subtract the sum. Now, the natural log of a sum, we cannot simplify that. All right, so this one is expanded. All right, then in number 2, this one I want to condense it. So I want to make it smaller, and I want it to be a single logarithm. So when I look at that -1, that might be a little perplexing, okay? And you want to think about property number 2. How could I rewrite this with the same base? So that's going to be -1 times log base 2 of 2. Okay, hopefully that makes sense. That's -1 times a 1. Then I'm going to use the power rule and bring the 4 up. I'll bring the 3 up, and nothing happens with that z. Okay, then this is log base 2. This is 2 to the -1. And then I'm just writing everything else down. Sorry, I'm squishing there. All right, then this, I'm going to group 2 at a time. That's going to be 1/2 times x to the 4th. Then, when you now do the subtraction, that's going to be division, and it's going to go ahead and hang out with the 2. And then I'm going to condense that, and that's going to be x to the 4th z. That's the product. So I'm just going in reverse there. All right, now this next idea, we do end up using this quite a bit in calculus. So it seemed a little bit silly last year in Algebra 2 because you could just use your calculators. And I know that, your teacher knew that. But we end up using that change of base when we are taking derivatives or antiderivatives in calculus. So that's sort of the motivation behind it. So here's the big idea, and we're going to focus in on, we're going to use all of them, but I really want to focus in on if I have log base b of a, you can change it to any alternate base. Typically, we use base 10 or base e and write log a over log b, or ln a over ln b. All right, so if you want to change from y equals a to the x to have a base of b, all you're going to do is rewrite this so that it is b to the log base b, a to the x power. And then you can bring that a down. So for example, if you want to change y equals 3 to the x to a base b, you would do y equals 10, and I've skipped a step here. Let me put the step in. This would be y equals 10 to the log base 10 of 3 to the x. Then you bring that x down, okay? And then over on this side, if I want to change a to the y equals x to a base b, I can change and take the log base b to both sides, bring the y down, and then that's log base bx over log base ba. Or just change a base. This could be log base 5x. All right, so let's look at example example B. So the first thing I'm going to do is I'm going to condense this as the product property, and then here the quotient property. So then that's log base 5 36 over log base 5 of 6. Well, I can use this property right here and change this to log base 6 of 36, which is in fact 2. All right, on this one, number 2, it looks really scary at first when in fact it's not. You can change this to, I'm going to use base 10. Okay, so if I use base 10, I can rewrite each of these. And then maybe you can see what's going to happen here. I'm going to slide it over because I write so large. This is log base 10 5, log base 10 4. And then hopefully you can see how much is going to cancel here. So those are all base 10s. Then watch. The 3s, the 4s, the 5s, the 6s, the 7s. And then what I'm left with is log 8 over log 2. And now I can use change of base. And that's 3. That's like really cool. Super cool. All right. Recall various forms of exponential models that are shown below. So we had the standard form that was y equals a times b to the x. You have the financial model, the continuous model, and the half-life model. You may have encountered the half-life model in chemistry, the financial model in a business class, and continuous model in biology. But each of them are the standard model written in a different way using a base other than b. You will notice I have bold-faced items in each model that are equivalent to b. In your university studies and in calculus, you will need to be able to change from one form to another. It is especially useful to be able to change from standard to the continuous model and back again. You will notice that the forms of these two models are similar in that y is equivalent to a, and then lowercase a is equivalent to p, and x is equivalent to t, as long as it's the independent variable. So b is equivalent to e to the r, and we can convert from one to the other. So in example C, it says convert each to the continuous model in base B. So watch what I'm going to do. This is like really interesting. So if I want to have E as my base, E and natural log are inverses. And then I can bring down, whoops, not the 2. I want to bring down the x. And there I have it. All right, so then I'm going to do the same thing here. I'm going to take it e to the natural log of this ugly looking quantity. And then I can bring down the power. And I realize you're not going to quite understand the why of what we're doing this, but just trust me, in calculus, we do end up using this. All right, then in part B, convert each of the following to a standard model base B. Okay, don't know that I went as far out in the decimal, but watch what I can do, okay? I can actually rewrite this. If I think about my exponent property, if I have e to the 0.015 to the x, do you realize I would in fact be multiplying? So then what you're going to do is you're going to put e to the 0.015 power, and that's going to be 1.0151 to the x. All right, then here, I'm going to do 1/2, and I'm going to change that to the 1/12 power to the x. Okay, and then, because that's my power to a power, and I'm getting 0.9439 to the x. And there you have it.